Okay, we are going to determine the form of a particular solution to this differential equation. As we can see, we have sine t plus t cosine t plus 10 to the t, right? All these three things on the right-hand side. So what we're going to do is, we are going to determine the form for first sine t, right, based off with sine t, and then another form based off with t cosine t, and then the third one for 10 to the t. At the end, we'll add them together. That will be the basic form for the yp. However, at the end, be sure you check for YH. Be sure you have to multiply by the t if necessary. So let's get to work. And you see, I have this in black, in red, in blue. So I will do the coloring accordingly as well. Anyways, so based off with sine t, ignore this at the moment, all right? Just ignore this for the moment. If we only have sine t right here, well, yp is going to be, keep in mind, for sine t, you must have sine t and also cosine t, right? So let me just put on sine t and cosine t right here. Well, we know we must have a constant here and a constant here. And this time, I'm not going to put on A, B, C, D yet, or maybe not in this video. I'm just going to use another way to label the constant. I'm just going to put down K1 and K2 for the constants, okay? All right, once again, this is based off with sine t. And now, next, we are going to base off with t cosine t. As you can see, t to the first power times cosine t. Because of cosine t, we must have sine t. And they are multiplying, right? So the cosine t and then the sine t, we will have to multiply by a linear term, right? So what I mean by that is, let's look at t right here, and let me just add them up. Let me just put it down here. Because this is the first power, I'm going to first put down a linear form for this. And I have K1, K2 already, so this is going to be K3. T to the first power plus K4, no T, right here, okay? And I'm just going to first put down sine T first, and then we add it with K5, T plus K6. And we are going to multiply by cosine T. And the reason I put down sine first is because I want to match the sine and sine here, and then we have the cosine here. The ordering doesn't matter, right? But anyways, this is what we have at the moment. At the end, we have 10 to the t to take care of. Yes, this is not e to the t, but it is still an exponential, right? So we can still do it the same way. So what I mean by that is the following. So for this term, we're just going to be adding. Let's put down the general form for that. For exponential, remember, the derivative of exponential, the function part-wise, it always repeats. But we may have different constant multiple. For 10 to the t, we still just put down 10 to the t. And all I need is just a constant right here. All right, so we use 6 k's already, so this is going to be K7. So this is what we have, right? Based off with that form, okay? All right, now, a few things are being repeated because, for example, you see this is the constant multiple of sine, right? Multiple of sine t. And this is the constant multiple of cosine t. Sine t times k4, sine t times cosine t times k6. This right here pretty much with that, and this right here pretty much match with that, right? So we don't have to have this many terms. In fact, I can merge them together. I'm going to put these two together, right? Because once again, you can imagine K1 sine t, and you add it with K4 sine t. Well, K1 plus K4 is just another constant, all right? So all in all, here is what we're going to have for the yp. I'm just going to merge that together. So let me just put down a linear term right here first. And now I'll use the A, B, C, D, things like that. Anyways, let's go. AT plus B, right? This is my linear term from here pretty much. And then we put down sine t, and then we add it with another linear term, which is going to be ct plus d, and we multiply by cosine t. And this is another constant multiple times 10 to the t. Well, I'm just going to put down plus, capital E is just a constant, times 10 to the t. Okay, so this right here will take care of these three, all right? Well, now here's the deal. I have to check for YH, right? So here we go. for YH, what I have to do is I have to solve y double prime plus y to be 0, right? And you see this is going to be r squared plus 1 equal to 0. And you know right away r is equal to plus minus I. So this right here, alpha is 0, beta is 1. So from here, you can just go ahead and put down YH has to be, YH has to be, whenever you have the I, remember you have the cosine and sine, right? And in this case, alpha is 0, so we don't have e to the y power. So it's just going to be cosine of 1, because beta is 1, so we have cosine of t, plus sine of 1t as well, like this. And of course, you can just put down the two constants, so let's put down c1 and c2. Right now, here is the deal. I see that here I have a constant multiple of cosine, and here we have a constant multiple of cosine, right? D times cosine. Likewise, constant multiple times sine, that match with this. How can we take care of this issue? Well, it's not that bad, because all I have to do is just multiply this by t, likewise multiply by that by t, right? And then of course, I'll finish this up nicely after we've done all this. I'll just distribute the t into the parentheses. So this one, at squared plus bt, okay? And then we have the sine t. And notice that you don't have another like constant term, because that will be redundant, because that will match with YH, right? All right, for this, just go ahead, ct squared plus dt. And this d is just a constant, it's not a big D notation, all right? So this is just cosine t, it's not a D notation right here. Anyways, this is plus e times 10 to the t. And this is the form that we are going to be using, okay, for that. And that's it.